Hi, this is Mr. Luis from Cerro Castilla, and today I'm going to explain to you properties of subatomic particles. So first of all, we have this information in your book, in which you're going to find out the properties of the subatomic particles. The properties are given on SI unit and also are given on atomic units. For this year, we're going to be using just the atomic unit, right? Because we're going to be analyzing just the general properties. So paying attention just on the atomic unit, you're going to find out that in the case of protons, the electric charge of them is going to be represented by a positive number 1 because the charge is positive. The charge of a neutron is going to be represented by a number 0 because its electrical charge is neutral. And in the case of electrons, the electric charge is going to be represented by a negative number 1 because the charge of electron is negative. In the case of mass, you see the mass of a proton is similar to the mass of a neutron. And in order to calculate the atomic mass of an element, we're going to take into account just the mass of a proton plus the mass of neutrons. Why we don't take into account electron? Because when you make this division, try to do it on your calculator right now, and you're going to see that this number is a number very small. So it's really close to 0. That's why scientists consider the mass of an electron as almost null. So for better understand this information, I already prepared a simulation about how to build atoms. Going to start over here. This is the planetary model that we're going to be using for this year. It's not the most appropriated one. Next year, you're going to learn more about it. However, this model is going to be useful in order to analyze the general properties of atoms. So at the center of this model, which is known as the planetary model, we have the nucleus of the atom. In the nucleus, we have protons, right? The same number of protons is going to be the number of neutrons. If you see right here, the simulation is giving me the net charge of the atom. Right here is telling me that the net charge is an ion, is positive. What happens if I add 1 electron? Now the net charge changes because the number of protons is the same as the number of electrons. So if an atom is going to be um, electrically neutral, the number of protons and electrons should be the same. What happens if I add 1 electron more? Then becomes into a ion, which is an imbalance, let's say, between the net charges of the subatomic particles. And in order to establish the balance, so I could add 1 proton more. And right here, I have to add a neutron. So right now I have the element that is known as helium. I want you to see the net charge right here. So since I have 2 positive, 2 protons, and 2 negative, 2 electrons, then the net charge of the atom, it is going to be neutral, so it's going to be 0. What happens if I remove 1 electron? Now the net charge changes into positive 1. Why positive 1? Because this electron or the electric charge from this electron, right, is on equilibrium with the electric charge of this one. But I have 1 proton more. So that's why over here, the net charge, it is positive. If I put back the electron that I removed previously, so you're going to see that now the atom is electrically neutral 1 more time. Now let's analyze the mass number of an atom. You see the mass number of an atom, it is 4. It's going to change the mass number of an atom if I remove an electron? The answer is no, because since I was explaining to you at the beginning, in order to calculate the mass of an atom, scientists only take into account the mass of the protons and the mass of the neutrons, because the mass of electron, it is almost null. So I'm going to put back the electron and I'm going to remove one proton. And if you see now the mass number or atomic mass, it changes, right? So this is all the information that I wanted to share with you for this opportunity. I hope you understood the information, and that will be all for this opportunity. Thank you for watching.